Good morning, Year 12. Thanks for coming along, guys. We're doing well already. I think we've got about 6 people on the register already done, which is great. I'll just hang around and wait for a little bit, make sure that you guys are all in. Sherlyn, good morning. Nice to see you. Let's see how long it takes before we get everybody in the classroom, shall we? I felt like there was going to be more people waiting. But I guess, it is a Wednesday morning. But just think you guys don't have school on Friday. Isn't that nice? Today, guys, we're going to be going through June 2018, paper 3. Oh, morning, Ipshita. Ipshita, this is an AS exam review. It's lovely to see you. I'm glad you attended. Ipshita, by the way, is a student from the UK studying GCSE. We're doing a paper 3 at Ipshita, which is the practical exam review. And you know what? This is going to be really, really interesting for you because you're going to realize just how much GCSE and AS level overlap there is by looking at exam paper 3 because it's the practical paper. The content is blurred with units 1 and 2. But there's loads of really good GCSE content here, and I'll just to explain to you that chemistry teachers have a really, really bad habit of not reteaching the GCSE content in the AS level studies. So what they tend to do is they tend to be like, oh, but you've already done this, so I'm not going to reteach it to you, and they'll set things like revision homeworks for students to do. It's not how I teach it. I teach the way that I learn. And in that particular case is the fact that I recognize that people forget almost immediately. You sit a GCSE exam, the next day you're going to have another one, and all of that chemistry just poof, disappears out of your ear. So it'll be really, really good for you to see the overlap, and I know that you're going to be taking AS level chemistry next year, which means it'll be really good for you to be able, and I'll highlight it to you in the webinar. I'll be like, make sure you learn this section from GCSE really well, because teachers have a bad habit of not reteaching it, and therefore when you get to AS level, you're just kind of assumed to know it all, and it's hard, especially since at A level, they take the understanding of these concepts a whole lot further. And so it'll be nice for me to flag up, and you're going to see an awful lot of it. If I'm going to make a prediction, I'd probably say about 50% of the content you're going to see on this A-level AS paper. Is this A-level chemistry quite different from AS level? Yes, it is. A2 is a similar step up. GCSE to AS is a massive leap, massive step up, especially for dual award students. But for triple award students, it's still an enormous step up. Hey, Ivan, good to see you. But going from AS to A2 is again, another big leap. But if you've got solid foundations, if you've got GCSE learned really well, and if you have the AS level really well, then it doesn't half make a huge difference. And I mean massive. And as I always say to my GCSE lot, anybody can do A-level chemistry. Anybody can. It's just whether or not you're willing to put in the time. It does take an awful lot of time and a lot of practice. I'm happy, Ipshita, I will happily share you all my supporting documents that I've given my year 12s. Happy to include you on it. So that way you can use and start to see the exam question booklets that I've created over the years. I'm doing A-level chemistry, just trying to bridge the gap and catch up on all your videos. Oh, Ipshita, you're so sweet. Thank you very much for coming. It'll be really useful for you to see this. As I said, what I'll do is I'll make the link between the GCSE and the AS. I'll try and make those, try and bridge that gap a little bit for you as well, if you like. So guys, this is paper 3. We're still missing a few people. Ria seems to be late again. And Ben is late again, of course. I'll mark them as missing for the time being, and then I'll fill them in later if they need it. Okay, so let's crack on, folks. Okay, so what I'm actually going to do is I'm going to load up iSAMs on my other laptop as well. That way, when they do turn up, I'll be able to then do that. Okay, so right, I'll share my screen with you guys. I still need to buy myself my webcam so that you can see my face and I can talk to you guys a bit more. You know, it's in the works. I haven't actually ordered one yet of Lazardia because I want to buy a decent one. They're relatively expensive, but I will do. I will. Okay, so let's crack on. So you can see my screen. I'm going to share this. So this is, I'll zoom out just a little bit. There you go. So this is Unit 3, Laboratory Skills. Yeah. So this is the practical exam. Now, if Ipshita's taking other exam boards, if she doesn't do IAL, the International A-Level by Edexcel, what they will do, Ipshita, is these questions on this entire paper, all of these questions are included in papers 1 and 2 of the other specifications. So these questions are all the same. They're just inputted into the actual papers 1 and 2 for the other ones. Okay, so we're straight into inorganic testing, and this links directly to GCSE, but of course it does make things a little bit harder. So it says the inorganic, so straight away, just want to focus on the wording here. Yeah, inorganic, of course, means that we're going to be ionic. We're going to be metal, non-metal. That's what this is going to be. So this is going to be an ionic compound, metal, non-metal compound. And it says contains a group 2, both contain a group 2 cation, but different anions. So we can say that we're going to have A is going to be our group 2 plus 2 ion, and our B is going to vary. Yeah, we're going to have 2 different Bs, but A is going to be the same for both. So what they're going to do is they're going to be testing for each of these particular ions using chemical tests from GCSE and AS. And it says they add dilute sulfuric acid and a white precipitate forms. Right, so clever question. So this comes up at GCSE when they're testing for the sulfate ion. So straight away, by the way, also, this actually is quite interesting because that's actually a little bit awkward because the sulfuric acid is going to provide us, it provides us with the SO4 2- ion. Students might actually be saying, well, hang on a minute, doesn't it also provide H+? Well, acids is in GCSE, the acid there is the test for the carbonate ion and it'll effervesce. But the sulfate ion, of course, is going to be picking up other different ions. So in this case, it's a group 2, and the chances are it's going to be barium, most likely. Now, can I just say, by the way, that that's actually a bit awkward because the barium, obviously, we know this test from GCSE. This is the test for the sulfate ion. And the test for the sulfate ion is barium chloride at GCSE, barium chloride solution, and I will form a white precipitate of barium sulfate. That's the GCSE bit. And of course, same AS, it hasn't disappeared. Now, this is a tad awkward because if you use sulfate ions as a test, you're actually going to be picking up other cations as well. If we go to our periodic table, now, of course, we're on A-level rather than GCSE. Nice for me to show Ipshita the difference. So this is often taught badly as well by teachers. So if you notice the difference, if I actually compare these two tables directly to each other, and what you'll notice is that at GCSE, the top number is a whole number. Yeah, the top number is just 9 for beryllium and 9.0 for beryllium on A-level. Well, some teachers will often say that this is just because it's more accurate. This is not correct. At GCSE, I'll try and shrink that down. At GCSE, what they're giving you is the most common isotope, whereas this is the isotope number 9. This is the most common, won't let me write up there. This is the most common isotope at GCSE. And then they have these really stupid idiosyncrasies of doing chlorine and copper with 0.5s, which they shouldn't do, by the way, at GCSE. They should make a decision and stick with it. Whereas at A-level, they are all now one decimal places because this is the true relative atomic mass. Yeah, this is taking into account isotopes. So this is actually the average of the isotopes. That's the difference between the average of isotopes. That's the difference between the A-level and GCSE tables. Nothing to do with accuracy. It's to do with the idea of one of them is a true average of the isotopes and one isn't. The reason why I went to that table, by the way, folks, was because it's nice to look at solubilities. We know that the sulfates of group 2, barium sulfate, of course, is completely insoluble. Strontium is very insoluble. Calcium is partially soluble. Magnesium, a little bit soluble. Beryllium sulfate, very soluble. So we get this trend. So technically, this could be strontium or calcium as well. Yeah, I'm just bearing that in mind. And look, 2 possible cation identities. So this could be barium 2+. So the white precipitate, by the way, a white precipitate forms. Yeah. So the people it could be is barium 2+, but it could also be strontium 2+, would be the top answers. Yeah. I wouldn't choose calcium over strontium because strontium is less soluble than barium is. Sorry, than calcium is. So more likely to be strontium than calcium. But great question though, and very interesting. A big step up from GCSE, but technically is GCSE content, which is really interesting. Test for the sulfate ion, but with this add-on of solubilities. Next, a sample of A was heated in a test tube and a glowing splint held to the mouth. The splint relit. Right, so that tells me that the splint relitting is going to be oxygen, but they also made a brown gas. And you have to know this. By the way, this is actually GCSE as well, but the chemical test isn't. Ipshita, I wonder if you could really impress me. Do you have, I wonder if there's any questions. Oh, Ben's just arrived. NAGSAC, always true. Absolutely right, Ben. NAGSAC's really, really useful. Like with the Castrobear and PMS, because I've seen some questions where it says it's slightly soluble and then not completely. Yeah, absolutely, Ben. All of those are super useful. Castrobear, PMS, NAGSAC, all really good for solubility. Keep using them. And they require practice, so I'm glad to see that you're doing it, Ben. Well done, really pleased. I'll just sign you in on the register, Ben. It's lovely to see you. Hope you're having a nice morning. Let's see if I can add you to the register. There you go. Ria's still not attending. If anybody could send Ria a message, that'd be really handy. But NAGSAC says. Says, go on, Ben. Says what? Now, Impshita, since you're there, I wonder if you at GCSE, can I just point out, this is a big, big leap. Do you have any knowledge of a brown gas? There are 2 at GCSE which you cover. List thing is insoluble. Yes, that's correct. NAGSAC are the lists of the exceptions to the rule, Ben. You're absolutely right. Yeah. So when do we know whether it's slightly soluble? When they compare it to someone else, Ben. Great question. So 2 brown gases that you guys need to know of, and only 2. Bromine, well done, Ipshita. Great effort. That is one of the 2 brown gases. Absolutely. It's not this one, but I am so impressed. Well done. Yeah, so the 2 brown gases you learn at chemistry for GCSE and A-level are bromine and NO2. Now, you learn that one at Pshita at equilibrium is where you come across NO2 at GCSE, and they learn NO2 in terms of thermal decompositions and stability of the nitrates. So the anion here is going to be NO3 1-. That's that one there. So that one is definitely into A-level at that point. Next, there were 2 gases evolved at A, was heated at brown gas C, D relit. Identify the 2 gases. So gas C, so A heated a brown gas C and D, which relit. So, and it just says the word identify. Lovely Edexcel do have some great overlaps from GC. The word identity means that you can give either a formulae or a name. They don't care in this particular case. If they say name and formulae, then you have to give those ones, but the identity means you can give either. So D, of course, is going to be oxygen gas, and C is going to be NO2. So you need to know your gases. And by the way, your gas test, your relit, is GCSE, not A-level. In fact, technically, by the way, I teach that to Key Stage 3. Name a test that could be used to distinguish between the 2 cations identified and include the expected results of the test for both cations. Right, really nice. So the guys, this is technically GCSE, but is actually slightly beyond GCSE because flame tests, and this is what I mean by teachers have a really bad habit of not reteaching it when there's extras that are now added. So Ipshita, at IGCSE, you learn flame tests, and you don't actually learn that many. Yeah, you learn like a very limited selection. You learn lithium 1+ being red. You learn sodium plus being sun yellow. Yeah, just being yellow. You get potassium plus being lilac, and you're not allowed to say purple or pink. And then you get calcium 2+, which at IGCSE Edexcel is orange red. Go figure. At all other exam boards, it's brick red, although they will accept orange red as well. And you get copper 2+. And that is the extent, and that's a green-blue is what that one is on flame test. So these are the 5 at GCSE that you learn. When you get to A-level, you all of a sudden have a whole load of extra ones that you now pick up. And those include barium 2+. Barium 2+ gives a yellow-green flame test. So it's just worthwhile learning these now, because and even though there's extras, it just means learning them now just means you don't have to learn them later on, and it becomes revision in your lessons. And strontium, SR2+, strontium is red, and a very, very red at that. It's as red as lithium is, by the way, but you actually have a problem with lithium and strontium. They often compare them and say, can you tell them apart? And you wouldn't be able to. Yeah, so what you would say is, in a test to distinguish the 2 cations identified, include the expectations of the results. So I'm going to say, first of all, we're going to do a flame test. Then I'm going to write a description of this. I'm going to say, use nichrome wire. Nice to give you all the extra bits. Nichrome wire is used because it's inert and high melting point. Use nichrome wire, dip in HCl. In HCl solution that cleans off the old ones. Yeah, dip in HCl, dip in solid sample. Now were they 2 separate samples? Were they 2 separate things? A inorganic compounds A and B. Okay. So A and B are actually 2 separate ones, which is great. Dip in sample of A, place in roaring, this is just me giving all the details of this, roaring blue flame, yeah, observations, green flame, green yellow flame. I'll put those back. It should be yellow green really, but it doesn't make any difference. Green yellow flame indicates barium 2+, and red indicates strontium 2+. Cool. I like it. I'd love to see Dat. You can do me a favor. Can you just check to see how many marks I get out of 3? And if I've missed any, that'd be great. A test was carried out on B. The observations made during the test are recorded in the table. Concentrated sulfuric acid was added to the sample, and an orange-brown gas evolved. Give the formula of the anion. Right, so your orange-brown gas. So on B. Now, this is interesting. A test was carried out on B. Yeah, so hang on a minute. It's rather interesting that, because they're telling me that it's a nitrate ion. Yeah, that's what the sample was heated is telling me this. Oh, hang on a minute. They have the same one. They have this, but they have different anions. Right. Okay, so that's great. So this is, will titanium wire be allowed? Oh, Ivan, no. You wouldn't use, why would you, in a very, very, very corrosion resistant, you're absolutely right. No, they wouldn't want you to use titanium. You're going to ask why, because nobody has it. Platinum, they'd allow platinum wire. Yes, they will allow platinum. They don't really like it. Again, nobody uses platinum because it's, to have a piece of wire of platinum that would be thick enough to be able to use in a flame test, you'd need it would weigh a good few grams. You're talking like a few $100s for a wire. Yeah, you wouldn't use it, but they will accept it. They will ask if they ask for an alternative. You would say platinum. Absolutely, Ivan. 3 out of 3. Thanks, Dat. I really appreciate your help. Right. So Ipshita, this now leaves IGCSE entirely. This question now is on redox and group 7. So we learn conch sulfuric acid, H2SO4, conch. I'm underlining that. Concentrated sulfuric acid with Cl minus, Br minus, and I minus. Yeah, and with Br, we're going to get bromine. So that's the orange-brown gas that we're seeing. But Ipshita, isn't that lovely that you know that observation already? Yeah, it's given you an orange-brown gas. We've already seen NO2 appear. There's only one other brown gas, and you've already got it, which is great, which is bromine. So the formula of the anion in B is Br minus. By the way, notice it's asking for a formulae. Yeah. Next. Okay, let's keep going. The identity of orange-brown gas given by name or formulae. It's bromine. Well, that's cool. That's really nice, isn't it? You know that one, Ipshita. NO2's already appeared, and bromine is the only other brown gas that we see. Next, 2 colorless acidic gases were also evolved in test B1. Oh, yes, okay. These gases were dissolved in water. Aqueous silver nitrate was added, and the solution gave a cream precipitate. Give the name. So, Ipshita, this is also IGCSE. Silver nitrate. I shouldn't circle it. I don't like that. Silver nitrate, Ipshita, dilute nitric acid, and with a cream precipitate. Can you tell me, Ipshita? Let's see if you can impress my year 12s. Give the name or formula of the gas. Ignore the gas for a minute. Suggest the identity. Ignore that one as well. Can you now tell me, Ipshita, what is that testing for? What is that the chemical test for at GCSE? Silver nitrate with nitric acid, and we get a cream precipitate. What have I tested for, and what is the compound? It's all GCSE that I have formed. It's proof in the pudding. Yeah, that's a terrible sentence. I apologize for that. It is that's a very old saying, isn't it? It confirms my previous test, which is really nice. So I know that there's a big delay on the video. We can do the other questions while she thinks. So give the name of formula of the gas identified by this. Oh, give the formula of the gas identified by this method. The gas identified is bromine. It's really interesting. Yeah. These two, hang on a minute. No, it's not. I tell a lie. It's not correct. We're testing for HBr. Yeah, just to quickly give you the equation for this year 12. We know if you add concentrated sulfuric acid to XBr, now in this case, we're thinking that I can actually add on my thing here, can't I? Because we've already identified the cation. Well, we haven't actually identified the cation, have we? It could be strontium or barium. So if I do that, what I'm now going to get is I'm going to get poof, big white cloud of misty smoke of HBr, followed by bromine gas, yeah, and followed by XHSO4. Those are the two things that we get. So we actually get 2 gases. Yeah. Now, what's interesting is we get 2 gases, suggest the identity of the other acidic gas by giving its name or formulae. Okay, 2 colorless gases were evolved in this test. An orange-brown gas, fine. 2 gases were dissolved in water. Well, we're going to get suggest the other identity. So we get HBr, and we get Br2. But it says, are they colorless? 2 colorless gases. I don't know what the second gas is. That's interesting. Oh, hang on a sec. What's my other possible structure? Interesting. Conch sulfuric acid. I feel like one of them is going to be sulfuric acid because it's going to be concentrated. But it says 2 colorless gases are also evolved in the test. What was the other anion? The other anion was a nitrate ion, anion A. Barium. Barium react with it? And that's a salt, by the way. That's not a gas being evolved. Oh, it's bromine. It's SO2. Oh, sorry. Took me a time. Sorry. I was focusing so hard on that. The last one is SO2. Yeah, because what's happening is the bromine, of course, the bromine is going from a -1 oxidation state down to a 0 oxidation state. Yeah, so that's going from -1, that's being oxidized. It's climbing the redox ladder. And the S is going from +6 down to +4. I'm an idiot, missed it, took me a while. There we go. Next, let's move on. Okay, this question is about organic compound X. Use all the information about X to identify the type of functional group present. Molecular formula, phosphoric acid with steamy misty fumes. Use all the information above. So, that there is the test for alcohols. So this is, and by the way, Ipshita, that again is A level. So you guys learn organic tests at GCSE. You learn things like the test for an alkene, is bromine water. You learn the test for a carboxylic acid, being sodium carbonate, effervescence. You also learn the chemical test at IGCSE of if you add sodium metal to an alcohol. You actually learn, and potassium dichromate, amazingly. They're just very rarely asked at GCSE papers, a bit hard. And this one is another test for an alcohol. So about X to identify the type of use all the information to identify, so we're going to say alcohol, type of functional group. Draw 4 possible structures of X. So we're going to have butan-1-ol. Yeah, going to have butan-1-ol. Can I just skip doing the H's today, folks, just to speed this up for me? It's only because I'm talking a bit too much, really. Butan-2-ol. Yeah, could also be 2-methyl propan-2-ol. I'll put my sticks on. I can't not do my sticks. If I don't, it upsets me. Yeah, and then stick. And then 2-methyl propan-1-ol. So you've done basic organic naming, Ipshita, but this is just a little bit further. It takes practice, but it's all right. There we go. Another test was carried out on X. A few drops of acidified potassium dichromate were added. This is you, Ipshita. Yeah, potassium dichromate, you actually already know that it's orange. Yeah, and it turns green in the presence of an alcohol. Yeah, that's what you learn at GCSE, and you learn nothing else. Yeah, that it turns green. But in this case, in A level, they learn a little bit more, that it doesn't always turn green. It only turns green in the presence of a primary or secondary alcohol, not a tertiary. So it stayed orange. Use the results to classify the type. It is a tertiary alcohol. I like it. Use your answer to part C to identify which of the 4 isomers it could be. And there's only one. It's that guy. It's always nice. It's the only tertiary alcohol that we have drawn. Yeah, all the rest are either primary or secondary and will be oxidized by potassium dichromate. Next, write an equation for the reaction between X and phosphorus 5-chloride. So, cool. So we've got equation. So we're going to have to do structural, folks. Notice the big gap. You could potentially draw it out. I don't think I want to. CH3, this is this guy here. Yeah, CH3, on to the next one. Let's go to this guy, which is C. And what's it joined to? I'm going to put CH3 as a branch. That's this guy here. Yeah. And then I need to do the other branch. Yeah, up there. So brackets OH. It's another branch. And then this guy at the end, CH3. There we go. I'm going to react that with PCl5. Now you'll notice I've made my writing way too big for this. So I'm going to actually shrink it. There we go. Going to react that now with PCl5. And what I swap is, in this case, I'm going to swap the OH for a Cl. So CH3, C, it's not a CH, it's a C. C brackets CH3, Cl, CH3. And I now get, I've swapped the OH for a Cl. I'm going to get Pockle, and HCl, I do believe. Is it going to fit on? Let's just check the balancing on this, folks. Yeah, let's check the balancing. Just going to get rid of some of these colors. Yeah, check the balancing. So on this side of the equation, I've got 4 carbons. I have got 3, 6, 7, 10 H's, H10, and then I've got a P and 5 Cl's. Yeah. Oh, and an O on that one as well. Yeah. On this side, I've got 1, 2, 3, 4 carbons still. My H's are 3, 6, 9, 10. Well done. I like it. H10 is there. I've still got 1 oxygen, which is great. I then have 1 P, and my Cl's add up to 5. There you go. So it still adds up. I like it. So that is the correct equation. I like it. Buckle. Cool. I always say that because it reminds me that there's 3 Cl's in it. I know I'm mad, but anyway. There we go. Done. Adds up. Okay. Infrared spectroscopy. So this is now, of course, still A-level Ipshita. This is all new, but not particularly complicated. This graph is actually upside down Ipshita. These are not peaks rather than troughs. Yeah. So it says, circle the peak on the spectrum that will not be present in the infrared spectrum of the organic product. Okay, so we're going to lose the OH bond. Yeah, it's no longer an alcohol. So that peak there, I'm going to make it a bit smaller. That peak there will disappear. It's nice. And that's because in an alcohol, I'm just going to do that. That bond there at Ipshita causes that trough there. Yeah, that's what it does. And now we've swapped it for a Cl. It means that trough is about to vanish. Yeah, nice and easy. So I'd circle that. Next. Is there any other questions? I feel like there might be. This question is about the preparation of crystals of hydrated sodium sulfate. Ipshita. So this is the preparation of salts from IGCSE. Yeah, and I assume it's just going to make it a little bit more challenging, but it's actually, this is potentially possible for you to do this entire question, which is 5 marks. This question is about the preparation of hydrate. You are provided with the following apparatus, materials to prepare a solution of sodium sulfate from sulfuric acid and sodium hydroxide. A preliminary rough titration shows that 18 centimeters cubed of sulfuric acid is required to react with 25 centimeters cubed of aqueous sodium hydroxide. Describe how you would carry out a second titration to find the accurate volume of sulfuric acid that reacts with. That's really interesting. In your answer, you should include color changes. Okay, so it has nothing to do with actual preparation of salt. This is a description of a titration, which once again, you have actually done at GCSE. Yeah, but you don't do it, you just don't do it with the level of detail that you do at A-level. You just cover it more. Yeah. So let's have a look, shall we, folks? So we know in a rough titration, yeah, you fill the burette with a funnel, yeah, you add it really quickly, yeah, until permanent color change. Yeah, that's the rough one. You just add it quickly until permanent color change. Yeah, that's the rough one. So what do you then do on the second one, the more accurate one? You do the same thing again. The rough one is called an overshoot. Yeah, you've done an overshoot. Well, what we're going to do now is we're going to add very quickly 90% of the volume that we added in the rough. Yeah. And then we're going to do dropwise near that endpoint. We're going to go back 2 centimeters cubed. It's going to be fascinating to see what description they want here from the mark scheme. So it says, describe how we carry out a second titration. Okay, bullet points. I'm not going to write this in continuous prose. It would be madness. So we're going to, how you carry out a second titration to find an accurate one. Okay, so I'm going to say it's 5 marks. A lot of space. I'm going to do the lot. Fill burette, refill burette. Refill burette with, what was I putting in the 18 centimeters cubed? So the sulfuric acid is in the burette. Refill burette with sulfuric acid. Sulfuric acid. Take initial reading. Take initial volume. Take initial vol. Yeah, and you're going to record it to 2 decimal places, brackets 0.00. Yeah, 2 dp. 2 decimal places. Next, we're then going to do take 25 centimeters cubed of sodium hydroxide using pipette, using graduated pipette. Place in conical, add a few drops of phenolphthalein. So I'm naming my indicator now, folks. Yeah, they haven't actually done that, have they? Yeah, they haven't actually done this. You should include color change of the indicator at the endpoint. Yeah. So add a few drops of phenolphthalein, and it will be colorless. Then add acid from burette. Add acid from burette to conical quickly at first, then dropwise as you approach the volume of rough titration. Stop adding when indicator turns pale. That's important, I think. Turns pale pink. Record final volume. Right. Dat, do me a favor. Record final vol. Can you see how many marks out of 5 I get? They stated methyl orange was used. What? Sodium sulfuric acid and sodium hydroxide. Oh, did they? Hang on. Where does it say in the question? Where is it in the question? Missed it. My bad. That'll teach me not to read the question. Thank you, Ivan. I definitely would have missed it. RTFQ, read the full question. Few drops of methyl orange. They're doing, by the way, you wouldn't use methyl orange. Stupid. It's not as good as phenolphthalein and in this particular titration. However, it does mean my indicator change is my color's different. Stop adding when indicator turns. So we've got it in acid, which is red. Hang on here. Yeah. So, yeah. Oh, no, hang on a minute. Sodium hydroxide's in the bottom. Yellow turns orange. And it turns orange. Done. Cool. How many did I get, that? Out of 5. Let me know. The results of the rough titration shown. There's the overshoot. Yeah. Ones used for the mean. The only ones we can use because they're within 0.1. That's actually a really interesting change, Ipshita. At IGCSE, concordance, which are values so similar we can deem the same. GCSE concordance is within 0.2. Yeah, but at A level, it's 0.1. They make it harder. Yeah, it's kind of nice that. Next, calculate the mean titer of these two. Oh, well, that's pretty easy because these are the only two. There isn't 3 of them, so it's just going to be, they're going to want me to show my working, 17.55 plus 17.65 all over 2 gives me 17.60. Lots of people will do that on their calculator and then lose that 0, but you have to have it. On the diagram, show the level of dilute sulfuric when the final burette reading is recorded in titration 3. 17.65. So there's 17, and we read top down. Yeah, so 17.6, and there's the 5. Yeah, so lots of students are going to do a straight line. You're going to lose it. Yeah, you will lose it. What you need to do is, you realize that most of it is flat. Most of it is flat, and then you need to go up at the ends. Like that. There we go. But the meniscus, we know that the meniscus, the water forms this rather cool curve structure. Yeah, and you always read from the bottom of it. Here's your eye here. Yeah, and you're always reading across the meniscus. Yeah, it should actually be touching the bottom. There you go. There you go. That's where you're reading it. 4 out of 5. Ooh, Dat, what did I miss? Which mark did I miss? Is it record final volume? Oh no. Work out the difference? What mark did I miss, Dat? Fascinating. Thank you very much for doing this. You're being a real help. Using results from table, briefly describe how you obtain a sample of pure crystals of hydrated. Using results from the table. Okay. It's weird. The final mark was for mixing it. Oh, for swirling. Ha! Love it. Whilst adding, you should swirl. Yeah. Swirl. That's amazing. Yeah, swirl whilst adding acid from burette. That's hilarious. That's amazing. Thank you so much, Dat. Putting that in red, really fascinating. One for me to pick up. The final, the acid and the alkali. Yeah, that's what they mean in that regard, I think. Yeah, you got to ensure it's all reacted. Yeah, the values, if the values were, which are concordant. Ha! Ivan, what a great question. Right, so let's talk about this, folks. So 17.4, 17.5, Ivan asked a really, really great question. 17.5 and 17.6. Right, Ivan is absolutely right. There is a problem in this scenario because what you realize is that this here is 0.1 difference. That there is 0.1 difference, but the difference between these two is 0.2. Right, Ivan, if you ever got that result, that's bad. Yeah, because it means you're not doing a very consistent job of the titration. That should never really happen. However, it does. And what you'd have to do is you'd have to do a fourth. You'd have to do a fourth to see which one is correct. Yeah, and just to tell you, chances are, and by the way, this question has only ever been asked once in my 15 years. And the question was super interesting because they broke it down. It was a suggest question. So the question said, suggest which two are most likely concordant. Yeah, and that was the question, and that's a really good question. I wonder if anybody knows A, B, and C, which two are most likely concordant, are the correct concordance? Which two are most likely to be correct? Yeah, that was the question. Wonder if people knows. A, B, A, C, B, C, A, C. Which one would it be? Yeah. The answer is A and B. That's the answer. The answer is A, B. The reason being is C is most likely to have been an overshoot. Most likely. You tend to go for the smaller of the ones because the smaller means that you've done it well and you've added it more accurately. The larger one suggests that you've just overshot it and made the indicator go too dark. The second question was, what can a student do? What can student do to confirm? Yeah. And the answer is a fourth titration. Fourth titration. Great questions. I've only ever seen them once. Fourth titration. Really, really interesting. Yeah, they didn't do it because I think a lot of people got it wrong. Just so you know. This is your bit of Pshita, the making of the salts. So we're going to say 2 marks using the data. We're going to add, you want to ensure that all of it is reacted. So we're going to add 25 centimeters cubed of NaOH to 17.6, yeah, to 17.6 centimeters cubed of sulfuric acid. That means you've got complete neutralization. Yeah. What we're then going to do with no indicator, you wouldn't use an indicator for this because otherwise you'll contaminate it and it won't be pure. Yeah. What you're then going to do is mix well. I'm adding it from that. Yeah. And then we're going to evaporate 80%. They want hydrated, you see, 80% of water, and then leave to cool down so crystals form. Filter out crystals, wash and dry. By the way, wash with acetone or wash with ethanol. Wash with ethanol and dry in, I don't know, drying oven with paper towel, maybe. Yeah, and dry with oven with paper towel. I don't think I'll mind either one. Dat, how many of the 2, please? I know our lesson's nearly over, folks. Wonder if I can do one more. I bet I can. Okay, so the last one, an experiment is carried out to determine the value of N in the form of a hydrated salt. I like it. You recognize these at Pshita? That's nice. Dat, 2 out of 2. Thank you very much, Dat. That's great. Mass of the content being heated. It's not actually equation. It's not actually draw the label, the diagram for the apparatus setup in heating of step number 3. Isn't that cool? So weigh an empty crucible, spatula in. Isn't that fascinating? Complete the table for 1 mark. I like it. So what I'm going to do is I'm going to end my lesson here because I'm not going to finish this in 5 minutes and I don't want to leave you guys going to lessons late. So what I'll do is I'll end this here. End of part 1. End of part 1. There you go. End of part 1. Right. Let's go back to here. Let's go back to here. Hey, guys. Guys, thanks for coming along. I hope you found it useful. It'll be great for you guys to be able to do this and to watch these for your A2. It only gets harder. But as I said, the more practice you get, you realize that paper 2 and paper 6 have got a lot in common. There's a lot of overlap in terms of practical-based skills. And so this will be really useful for doing your A2 in Unit 6. But guys, what if the salt is soluble in ethanol? It's a very good question, Kayan. The answer is most salts aren't very soluble in ethanol. The answer is that if the solubility was there, it would be very, very low. Do you know, on the mark scheme, it probably says wash with water, which really annoys me. Because if you wash it with water, you're going to dissolve all your salt and it vanishes. It really drives me nuts. GCSE, Edexcel, they want you to say wash with distilled water. Kills me. Kills me. For a hydrated salt. For a soluble salt. If you do that, you're going to wash it and go, oh, crystals are gone. It's like, drives me crackers. But yes, Kayan, it will always be low, so you'll lose the minimum amount. And by the way, that comes, of course, again at A level. So you would, in order to make sure you don't lose much, you would wash with the minimum amount of ethanol, and it would need to be cold. I think we had that on the previous one. The previous one was much harder. It said ignore any drying washing. There you go. Yeah, amazing. But That's definitely better to be more thorough. Yeah. It is because of the lower overall polarity. Yes, it is. Yes, that's correct. It's because water is very, very, very polar, whereas ethanol, it's overall polarity. The carbon chain also reduces the solubility of things within it. Yeah, because you're introducing, rather than water, which is 2 hydrogen bonds per molecule, yeah, ethanol's only got 1 per molecule, means that which it'll reduce the solubility of the salts in that solvent. Great question, though. I wrote boil off half of the water, but the mark scheme says evaporate. Is that the same thing? Yes, it is, Ivan. You can have the mark, but in future say evaporate. You're going to say why. In reality, you are boiling it off. But the reason why they're trying to make that distinction is boiling is quite a violent process. You know, they bubble, and you can imagine evaporating dishes going, this. Yeah, and so you don't tend to like boiling it because it just becomes really like things fall over when you boil stuff because it's quite a violent process. And evaporation is, of course, doesn't produce all the violent bubbling, which means it just makes it more stable. So it's just nice to add it. Nice to make those adaptations, just like I did. The mixing one, it's nice for me to recognize. So for any titrations at A-level, you're definitely including that concept of swirling when you're adding the acid from the burette. Nice adaptations to make, definitely. Guys, go and have a great rest of your day. It's been good to see you. I'll see you all soon. Take care.